Welcome to the day 5 of the machine learning project. So in today's class, we're going to be introducing the gradient boosting algorithm. This is an introduction to advanced machine learning technique. So for those of you who are in class today, welcome. And those watching on YouTube, you're welcome to today's lecture. So let's begin. We're going to be looking at the objectives. At the end of this lecture, you should be able to understand gradient boosting concepts, training and tuning an XGBoost model. Also, by the end of this lecture, you should understand how to visualize learning curves and feature importance. And finally, you're going to learn how to save the XGBoost model for energy prediction dashboard. All right, so understanding gradient boosting concepts. We're going to look at 3 points. Number 1, the basic principle of gradient boosting explained simply. Now, gradient boosting is a powerful method that combines multiple weak learners to create a strong predictive model through iterative improvement. Secondly, let's look at how gradient boosting minimizes error in prediction. Now, by focusing on the mistakes of previous models, gradient boosting effectively reduces residual errors, leading to more accurate predictions in complex datasets. Thirdly, we're going to be looking at the key components that make gradient boosting effective. Now, gradient boosting relies on decision trees, learning rates, and loss functions to refine predictions, enabling it to adapt effectively to different data patterns. Now, it's good for we to understand the concept of gradient boosting. Now, gradient boosting is nothing but a machine learning technique that builds on an ensemble of decision trees sequentially, where each new trees attempt to correct the error, which is the residuals made by the previous tree. Key terms: weak learner. A weak learner is a model that performs slightly better than random guessing. The term ensemble simply means a combination of multiple models to improve overall performance. And this is basically the technique behind XGBoost. Residual, as the name implies, this is the difference between the actual and the predicted value. So the residual is known as the error. So in gradient boosting model, we try as much as we can to reduce or minimize the difference between the actual and the predicted. And then finally, we have the learning rate. The learning rate is the scaling factor that controls how much each new model affects the final prediction. So this is nothing but the step size that controls the training process of the gradient boosting model. The question that comes to mind is, why choose XGBoost for machine learning? Now we're going to be looking at 3 key aspects. Number 1, high performance and speed in training models. XGBoost offers exponential speed in training, allowing models to be built quickly and efficiently, making it a favorite among data scientists. 2, handling missing values effectively with built-in strategies. XGBoost ability to manage missing data automatically helps improve model accuracy without significant pre-processing effort, which saves valuable time. Now, we saw from previous lectures, using linear regression and random forest models, we need to carry out a pre-processing techniques, processing procedures in order for we to prepare our data set for training, such as handling missing values, such as carrying out feature engineering, and all of that. In gradient boosting, all those pre-processing steps are done automatically, right? So this saves time. And then thirdly, robust regularization to prevent overfitting issues. With built-in L1 and L2 regularization, XGBoost effectively reduces overfitting, leading to improved generalization on unseen data, which is essential for reliable prediction. XGBoost is indeed an advanced machine learning model. Now, the next thing is to understand how to install XGBoost model. All right, so we're going to look at the step-by-step guide to install XGBoost and access its official documentation for users. So the link has been provided for any information that you want to get about XGBoost. All right, so to get started with XGBoost, you need to install the package using the following command in your terminal. So you use pip install XGBoost. So this ensures a smooth setup. Loading data and preparing the input for XGBoost model. Now, in day 3 lecture, we use features created, okay, during the pre-processing stage. And then we have a snippet of what the process looks like, where we import the Pandas, the XGBoost model, and also the metrics, which is nothing but the data structure technique, which is embedded in XGBoost. So XGBoost has an inbuilt data preprocessing technique that stores and processes data efficiently and quickly. So loading the data using the command and passing the date for date time, and then as well sorting the values based on date for real time, for time series data in order to avoid data leakage. And then splitting features and label. Now, to define the features, we have to drop some columns like the date time and the global active power, because the global active power is assigned as a target label. So we're going to assign that to Y, which is the target, and then go ahead to create the D matrix for XGBoost, where we set the variable D train equals to the D matrix into bracket the X comma label, which is equals to the target Y. All right, so a D matrix is XGBoost internal optimized data structure, which is used to store features and labels efficiently for training. All right, so cross-validation with xgboost.cv. All right, so this is another method of data partitioning. We have 2 methods. We have the train test split, and we have the cross-validation. All right, so the cross-validation helps avoid overfitting and gives insight into models' generalization ability. However, in time series data, we usually don't employ cross-validation split method because it's going to allow for data leakage, where samples, newer samples will be included in the training set and older samples will be included in the test set. So in this case, we won't be able to preserve temporal order in the time series data. So cross-validation method is extremely discouraged in time series data, but it's encouraged in other forms of data set that is not time dependent. All right, so training your model or training your data set using time series data set or other forms of data set, you can follow the same procedures whereby you have to set your parameters and then for the training and also for the cross-validation result. All right, so for cross-validation with sgboost.cv, the parameters that has been chosen is explained as given. We have the objective, which is the main target of the machine learning model, which is to reduce the difference between the actual and the predicted using the loss function, which is nothing but the square mean error, okay, for regression tasks. Then we have the learning rate that controls the learning process of the model, which is nothing but the step size. And then we have the maximum depth, which is chosen to control the depth of the trees. Then we have the subsample, which is a fraction of the sample used per tree during the numbers of boosting, the boosting round. And then we have the column sample by tree, which is the fraction of the features used per tree during training. All right, then we have the output, which prints the result of the cross-validation. So we look for the lowest test RMSE to select the best number of boosting rounds, which is nothing but the training time. All right, so we fit and save the model effectively. So you're going to learn how to properly fit and save your XGBoost model for future use in machine learning projects. Now, fitting the model simply means to train the model, which is crucial for optimal performance. Once fitted, you can save your model to reuse it without retraining. All right, so the snippet of the code is provided for the training process of the XGBoost model. And then we can use the job lib to serialize our model for later use, as presented in the snippet. Now, understanding XGBoost result visualization. So we're going to explore how to interpret and utilize visualization to enhance model comprehension and performance analysis for machine learning. Now, visualization are crucial in understanding model performance. They help in identifying patterns and improving our machine learning models for better predictions. So we're going to use the Matplotlib library, where we have the xgb.plot underscore importance. We have the model we have trained, which is the final models. We have the maximum number of features, which is equals to 10, and then we have the phi equals to 0.5. In this case, what we have set is we want to see the top 10 features, the feature importance. These are the features that contribute to the prediction process of the XGBoost model. And then that is going to show us what are those features that contribute more to the predictive outcome of the model. So this is a straightforward plot that helps us visualize our model performance. And then plotting learning curves is important to see how the model converges during training. So we could see the behavior of the model, how stable the model is during training, and at what level, at what boosting round did the model begin to converge, and how the model behaves. Is it during the early stage of the boosting round, or is it the later stage of the boosting round? So these learning curves tells us the behavior and how the model is learning through the process of training. All right, so thank you so much. If you've gotten to this part of this lecture, it means you have gained some considerable amount of knowledge on how XGBoost is trained. So stay tuned as we move to the next section of this lecture, which is the coding. So see you at the coding session. Bye.